This is question number 1 from the 2002 AP Calculus AB exam. Okay, so we've got an area and volume problem here. Our two given functions are f of x equals e to the x, so that's exponential like this, and then g of x is ln x, which increases like this. So there's our g of x. So for part A, we're looking for the area between f and g, and we're looking at a small section just between 1/2 and 1. So just here to here. So that would be the integral from 1/2 to 1 of the height of the rectangle, which would be pink minus blue, f of x minus g of x. And we use our calculator, and you should either get 1.222 or 1.223. Okay, part B. Now we're looking at volume. Still between x equals 1/2 and x equals 1, but we are revolved about the line y equals 4. So y equals 4 would be some horizontal line up here. So we're going around here. I'm going to draw in my rectangle. And it looks like I'm using washers. So the coefficient is pi, and we're going from 1/2 to 1. Now we need outer radius squared minus inner radius squared. The outer radius is going from 4, right, 4 to the blue, to g of x. So 4 minus g of x squared minus the inner radius is from the axis to the top of the rectangle here. So 4 minus f of x. 4 minus f of x squared. So our answer could be 7.515 times pi, or if you multiply that out, it's 23.609. Now part C, they are giving us a new function. H of x is f of x minus g of x. And we need the absolute minimum value on the closed interval and the absolute maximum value on the closed interval. Okay, so first let's find our critical numbers. So that happens when the derivative is equal to 0. So the derivative of e to the x is e to the x. Derivative of ln x is 1 over x. We're setting that equal to 0. Now, this is going to be difficult to do algebraically, so you can do one of two things. You can put this in your calculator and either type in this whole function, e to the x minus 1 over x, and see where that crosses the x-axis, or you can put this in your y1 and put 1 over x in your y2 and look for the point of intersection. They should be equal. Now that point turns out to be something like that. So that's our only critical number. Now we know that absolute extrema can happen at the critical numbers or at the endpoints. So we need to find h of 1/2, h of 1, and then h of 0.567. That's 6 there. Let's see, 0.567143. So h of 1/2, and again we're using our calculators, that's e to the 1/2 minus ln of 1/2. That turns out to be this. h of 1, that's e to the first minus ln of 1. Well, ln of 1 is just 0, so we're left with e to the first, which is 2.718-ish. And then we plug in this big decimal. Use as many numbers as you can, and you should get 2.330. So it looks like the absolute maximum is, where's our maximum? This would be the largest number, so it's h of 1, which is 2.718. The absolute minimum is, well, that would be h of 0.567143, because that's the smallest of the three numbers, and that is equal to 2.330.